Welcome to Virtual Laboratory. I am Professor Uttam here. Today I will demonstrate virtually a bomb calorimeter for determination of heating value of a fuel. Usually solid or liquid fuel is used for determination in this experiment. Now in the beginning I will scale down the time for the experiment which is time consuming. So before that I should say that the bomb is a pressure vessel, small type, which is not exactly cylindrical, it is somewhat spherical, hemispherical, and different shapes are available. Usually it is looking like a bomb, that is why it is called bomb, and it's a pressure vessel, and within which a igniter is placed electrically connected, and there is a cellulose wire or rope which is placed here in contact with the fuel sample taken in this cup. This cup is hanging or supported within the bomb, and the entire bomb is placed in a calorimeter provided with a starter and water, and this bomb is initially filled with oxygen under pressure so that complete combustion may take place. So now we'll start at the beginning. We take say petrol as the sample, which is hardly 5 cc or 10 cc sample is taken as prescribed in the ASTM standard method. So here it is a sample taken in the bomb, and it is now closed, and the starter will be started and the ignition is on simultaneously in this experiment, and we'll find that the starter is moving and the bomb ignition has taken place, and the combustion is shown by this reddish value for some time, and then we get the time temperature curve which is recorded automatically or supposed to be taken by the student time to time with the thermometer placed in the calorimeter. So the water temperature in the calorimeter and time is measured now, which is finally these are calculated by average temperature calculation is done by taking complete area of this, that is the total area multiplied by divided by the total time within which this heat transfer has taken place. That is, it started at the beginning from 20 degrees centigrade at the room temperature and goes to a maximum 29, and then it starts cooling, and then it falls gradually, and it will take time, and we take this time, the difference, and within this the area is calculated and the average temperature is measured. And the average temperature of the water after explosion or thermal combustion, that with respect to the initial temperature of the calorimeter water is determined, and finally the heat is calculated by multiplying it with the water equivalent of the calorimeter, which is around 6000 per degree centigrade in joule per degree centigrade. So we can calculate the heating value. Obviously the weight of the cellulose wire which is connected here for aiding burning or some weight is taken in the beginning of the experiment, and this calorific value or heating value of that cellulose is known, which must be deducted. And so after this correction we get the heat transfer. This H stands for higher heating value in joule per gram is calculated. It is higher heating value means gross heating value. There is water inside this bomb, whatever is been converted from hydrogen of the fuel, which is converted to water, and it is completely condensed with this temperature. As a result, the latent heat taken by it is returned, so we get the total heat developed. So it is called higher heating value or gross heating value is calculated. So that is the experiment for petrol. Now we can try with your another sample, say it is kerosene. So we take kerosene in a sample, it's slightly bluish in color, and then the igniter is on. I will find that initially suddenly it goes the red because of combustion, indicating the temperature, which you cannot see, but you can see the rise of temperature. And then as soon as the combustion is complete and cooling is taking place, as heat is transferred to water in the calorimeter, you will note down this temperature versus time curve, which is around 28, around 27.5 plus, that is around 28 or so. And then we get the average temperature and minus the initial temperature, and is divided by the time within time domain within which this area is calculated, the average temperature, and the difference of this with respect to this initial temperature of the water in the calorimeter multiplied by the water equivalent of the calorimeter. We get the total heating value. Obviously, a correction has to be made again for the cellulose ware which is used, and the heating value of that amount for the quantity is taken. That must be weighed in this weighing scale before you connect this cellulose wire. So, and sufficient oxygen pressure must be maintained to provide complete combustion. That has to be remembered. Now I will show for the next experiment. Say we scale down the time and take diesel, and say diesel is slightly yellowish, its color is looking white here, and now the igniter is on, and you will find again the similar explosion or combustion takes place, and the time temperature record is carried out. From this, average exit temperature is calculated, and then finally we get the heating value by multiplying the difference of the maximum average temperature, that is, you have to calculate the area under, as I have already told, and then the heating value is calculated. Obviously, correction has to be made again for the cellulose wire which you are connecting. And so initially, this is the experiment. This is simplest experiment looking to be in the computer, but this is a kind of demonstration how to carry out the experiment. But it is a time-consuming experiment, as you know, that you have to clean the bomb, and it has to be properly fitted in the water calorimeter. The liquid must be clean, and this is properly placed in a insulated vessel, and the top also will be covered with the insulated cover that is not shown here, so that no heat is lost to the surroundings. And this igniter, before you place this, you have to connect a cellulose wire or rope, so that which will burn to aid the combustion, without which it is impossible for doing it. And this bomb calorimeter, as you know, is utilized for determining the heating value of solid fuel like coal, coke, or even liquid like gasoline or petrol, kerosene, diesel, and any other petroleum oil. That's all I wanted to tell about the bomb calorimeter experiment. Thank you very much for watching this video.